definitely help to get your profile picked. So I was like, it's like small things, but that builds up. I feel like
Yeah.
so now the market obviously it's closed. So now no one will get job at least for next 2 months. So the job openings will open in like Jan Feb. So now like by December everything is closed now. So I'm hoping that in Jan Feb when the new budget comes, new openings open every time it happens every year. So as like I'm hoping that by that time I'll get my GitHub profile a bit good in a good way so that I when I'll apply I should be able to get calls.
Mm-hmm.
That's what
Mm-hmm.
I'm hoping.
Yeah. That makes sense. Y'all want to hop to it? We'll pop right in, man, because I definitely want to start working through this. So let's go. I'm gonna go ahead and share my screen and just to like do a quick little overview of what we did yesterday. Did you have a chance to explore the data? I know you mentioned you were gonna do that a little bit of detail.
No, I couldn't. I was just doing it now. I did a local setup because there was some issue with my Google Colab, but now the local is ready. So I just ran like exactly what commands you did, and I was just seeing the data.
Mm-hmm.
So I'm gonna like do it like I'm gonna actually like let's proceed with like I mean we don't I feel like uh what I was thinking was what if like we just try one model like without doing any EDA, just like run one model and see what the accuracy comes. What do you think?
Like right here, you're saying just do a model.
So like what we are doing is we are basically doing some data analysis, understanding the correlation and all, right?
Mm-hmm.
So I would say like let's like just do the correlation and just see the correlation whether we need a linear model or like a logistic model and like see how what is the correlation of different variables with trip duration and then directly just run one model straight away for now. I mean I
Mm.
just want to see like what how the model runs and what's the accuracy. It might be like really bad, but at least like I want to see what exactly happens. So I was just thinking in that way.
So you just want the next code that we run to just run a model. Like we'll do the correlations and then we'll just run a model. You don't want to explore and visualize the data.
As a base I want to like just do it as a base model but then we'll do the exploration. It's not like that would be a final
Oh,
model.
oh, 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 okay. I thought you meant like skipping everything and just jumping
No,
straight.
no, no. That's not how it works.
Yeah.
Yeah,
Okay.
I don't.
Okay. All right. Cool. So I guess we'll do the correlations. Let me pull up the GitHub repo too, so I could just see what that code looked like.
You
Um.
wanna you wanna do the graphs there with all the data,
No.
not just the first 10,000,
Um. Yeah. 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 True. True. Oh
because we
yeah.
don't
Because
know.
we were only. Yeah. 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 True. True. True.
We don't know if that the first. We don't know how the data is sorted. So if it's randomized, then maybe the data looks the same. The 10,000 looks like the rest of it, but maybe it's sorted in some way where it's not given a good full picture of things.
Yeah, I guess 10,000 was pretty quick too. It did it in just a second. We could go ahead and just try that out while I go ahead and find this code here.
Well,
The code.
the guy made a good point yesterday that when you're doing things to see, well, will it run and do you have it right? It is a good idea to do it with a small subset of the data and
So
just
this
to
is
see
all the
will it still
data.
run.
This is all the
Oh,
data, and it already executed. So, but for some reason, yeah, see. So, but for some reason, it's just showing really skinny. So, do you guys know how to zoom in on that?
is it a matter of that? Yeah, that bins. Um,
Mm, I
or
mean,
I mean,
are
one, two.
there
uh,
outliers that are so small we can't see them that are forcing, that perspective of um
but like you're talking about thin, like you can see the scale, right? So you can understand through the scaling. So you can see the scaling for like the trip duration, like if you see the scaling. So just do one thing. There should be a way to change the scale actually. Like if we like increase the scale,
It's
then
not.
that would give us like a zoom in
It's not
feature.
figure size, is it?
No, no, the scale, I think there should be a parameter of X scale or Y scale. I'm checking
Mm,
that.
we have X tick.
I think, yeah, I think so. X tick is like the parameter, but that X tick would have some additional attribute, which would be like scale or something. I'm checking that.
Yeah, there's probably
Yeah,
one that
why
we're not including right now.
why did it work on the last time you did it and not?
Because this is just including way more data.
Yeah, but it's in the same range. You know, it's not like
No, it's not. It's not in
right?
the same. No, it's not in the same range. This one is negative 74.2 to negative 73.8. This is like negative 60 over here. So the range is much bigger. Yeah, this one goes all the way to negative 60 and negative 110. So the range is way bigger in the pickup longitude here than it was here. I don't know what's changing the range. There's got to be some type of setting. So while I find the correlation, feel free to do a little GPT or Google search. Let's see, correlations. Correlation. So, housing core, numeric only, true. So we're only going to get correlations for the numeric data. Correlation matrix equals df dot core numeric only equals true.
You know, for those graphs, it may be that there's outliers that are so bad that it's.
Nah, it's just the scale. Oh,
Yeah,
you're
but
saying, oh, you're saying that
like
there's outliers that we just can't see? Yeah,
like
true.
there's one that's like that minus 100, and that's why the graph is showing that scale.
Yeah, but we should
But
be able to
once
create our scale though, right? That's what we're saying.
No,
We want to just create.
yeah,
Yeah, I think the scale is assigned dynamically because every parameter has its own range, right? So I think like if we change the scale, it would affect everything. So I don't think you'd be able to change the scale. But the thing is, I think from the data, I can understand that like what the 10K records which you chose, like I think the graph is correct actually because like I think how much data is there when you are doing that the you when you're doing the distribution, the histogram distribution, like is it like 10K records only?
This one here?
Yeah.
No, this is all of them. This one is 10K. So like Sweeper said that there's less likely that there's like a crazy outlier here. You could see that there's one here, there's one down here, but when you look at the drop off latitude for here, there's probably some outliers we just can't see because it's too thin. So we're including outliers here for sure. For sure.
You can at least, well, it at least tells us that that one line is where pretty almost everything is.
Yeah. All right.
And it's you could almost say that anything that's not on that line is something that can be maybe disregarded.
I think visualizing that large data is having some issue. It's not the scaling, but I think we need to visualize like samples, like rather than the entire population, like just the sampled population basically. So yeah, I think it was right. Like, but like one thing what we could do is like there's one more way is like we can choose like random sampling function to randomly sample a certain records from the population, like the entire data set, and do that instead of like taking only like first 10,000. So that is one more way.
But we
to,
could
like,
also just get a range to. Hold on.
Yeah.
It might be you have to do one graph at a time, and then you can set the range that you want on it.
No, but if you change that much scale, all other plots will get changed.
Yeah, no, I'm just looking.
Yeah, sure.
Okay, so range. All right, yeah. So if we wanted to, we could drill down and do like DF. So if I did something like here, let's try this out. So if I do DF, let me see the one I want to do. I want to do drop off latitude. So I could do drop off latitude, and then I could do hist bins 50 range 40.6 to 41, and fig size equals 12 and 8. I also want to include this stuff here, although I already did, but let me just double check. There we go, and then I'll plot it, and we should just show. So this one here should just show the drop-off latitude with all of them, the 1.5 million, but only within the range of 40 to 6 and 41. Yeah, there we go.
Yeah. Oh, okay. Yeah.
Yeah. Though,
Nice.
though we don't want to include just the range. We want to actually see all of them. So in this case, bins. Yeah, so there are definitely outliers here that we just can't see. It's just too much data for us to even see.
Yeah, you could say if you wanted to really see what are the outliers, you could look at the number of the mins, the maxes. Maybe you could even do a query that says, give me what's greater than 41 and less than 40.5, and see what that comes with.
There we go. So this could zoom on like where most of them are happening, but that doesn't include our outliers. But we could definitely see it a little better. And since we're this zoomed in, I'll definitely want to get more bins. I would definitely want to get like a better. That's probably too much, but at least it gives us like a basic idea. Yeah. Okay. Cool. So yeah, we would want to keep this. Anything outside of this, we'd basically want to cut it out, right? Because if there's any outliers outside of this range, we don't want them.
Probably, but one of the things that'd be interesting is the geographical plot. Just like the California plot of homes.
Yeah. I want to do. Yeah. I want to do
that
for sure.
That could tell us a lot, and then we got to figure out. We know how to. We know how to from the California one. We know how to sort of plot a point, but is there also a way to, draw a line between the start and the end, or will it be too much of a mess to do that?
Yeah, that would be
think
maybe,
right?
Yeah, I think it'll
but-
just be a big mess, but we could try it.
But maybe on the first just like try to plot the points, and maybe if it's possible have like the start points be one color and the end points be another color. But
Right.
like go step by step. We know how to plot points, so if you that'll be interesting to see.
Yeah. All right. Cool. All right. Then you figure out like what the code is to plot the points, and then Aditya, do you have the code for the model yet? You said you wanted to run the model after we checked out the core. I mean, I have the correlations here now. We didn't even look at them yet, but basically what I'm seeing is there's I don't see any strong correlations.
Yeah, so that's why like I saw that. That's why I'm also going into plotting the model only. Like the plotting the latitude longitude. I want to see like because the thing is those pick up latitude longitude points, they cannot be individually considered for correlation because they need to like somehow be considered as a group or something, because they won't be able like just like those 4 points that pick up latitude, pick up longitude, drop off latitude, drop off longitude, though they will never be like they won't have like individual relationship with the trip duration. So they cannot be considered individually, but like some kind of metrics as a combination. So that's what I'm trying. So I'm just
Yeah.
thinking about that. Like what could be like the metrics we could use to relate with the correlation thing. So I'm trying to check that.
Well, you know, it's in the California thing. They did that by combining like they had the bigger circle, so that was, it might be sort of similar to what we're talking about here. You know, you when you have a lot of dots in the same area, you create a bigger circle, and that I don't, maybe that was just a visualization thing on the California thing, but it can also be a way of grouping things and then considering them as a group.
Is the distance still correlated to the Grand Central and the pickup location?
I think so. But yeah,
Is it?
that should be. I think so. I don't. We haven't unless Jim worked overnight to change it, but I think it still is.
No, I didn't. What was the question?
It was we had the the Grand Central like to the drop off location instead of handling the pickup location and the drop off location.
Yeah, that's the distance. That's the distance here, and that's actually what this is saying. So I just asked, how can I combine the latitude and longitude attribute in a machine learning model to create a more accurate correlation? And that's one of them. So feature engineering is just distance features, calculate distances from key locations. So we did Grand Central Station, which can be more informative than raw latitude and longitude. Clearly, it's more informative because, well, longitude is a little more of a positive correlation, but latitude is a negative correlation. But they're both 0.02, which is still not good. And then you could also do geographical binning, so grouping latitudes and longitudes into bins or regions. This can help in identifying region-specific patterns. So I wonder if we're able to break up like New York City into like neighborhoods or something like that. We could definitely do that. I know that for sure. I don't know what it would take, but we could definitely do it. And then interaction terms. This was my intuition. I was like, can we like add the pickup longitude to the pickup latitude so it like equals a number? But I could see there being problems with that because there's going to be times where the pickup longitude is like a little further north and the pickup latitude is a little further south, and so they have the same values as one that's further south and further north. Like I could see it balancing out in some inaccurate ways.
So one thing which I can think is, so one correlation would be basically the distance from the pickup latitude, pickup longitude to drop off latitude, drop off longitude. So that should be positively correlated with the trip duration. That's one thing which I can think. And the second thing is, somehow if we could find out so mostly like what could be the reasons for the trip duration to be larger. One thing is the distance. So if the distance is high, obviously the trip duration automatically gets larger because it is. But like what if like the passenger count is higher? Like passenger count somehow would matter because let's say if like I don't know if there are like different modes of different types of cabs basically. Let's say if it's like a 6-seater or like a 8-seater or like a 9-seater, obviously it would be like I don't know, like just logically it would drive a bit slower than like a 2-seater cab probably.
You know what I want to do? Because I think that even more important than distance, look, my girl lives in Queens, man. Like she tells me she tells me that depending on the time of the day that she takes the taxi is like a huge factor in how long it takes to get to a certain place. So the problem with these correlations here is that we don't have that included because what we have is a date object. So we need to find a way to convert the date and time objects into numerical data. Because once we convert the date and time objects into numerical data, I bet you those are going to be more of a positive correlation than anything else. Like, sure, distance is okay, but the time of the day, there's times where during the day, at certain times between rush hour, before work, like on the way to work or coming home from work, where even if it's like 3 miles away, it's going to take you an hour and a half. You know what I'm saying?
Yeah, then convert it into timestamp. Timestamp is a numerical value.
Yeah. So we definitely need to do that.
Yeah, I was going to say so that would be like one factor, the date and timestamp. Like vendor ID, passenger count, I'm a bit unsure, but passenger count could go with some other parameter to correlate with the object. So that could be an additional thing, like a combination of parameters. But that we need to.
Yeah, I think we need to find a way to normalize the whether they have service or not too, because I think we made this acknowledgement in the beginning too, was just that if there is service and they don't have any network connectivity issues, that the trip is faster. It's always faster, and it's actually going to be even faster when we cut out those anomalies, the errors, the outliers. So those are a couple things I'm thinking about. But I have one question. If distance from the pickup longitude and pickup latitude to the drop-off latitude and the drop-off longitude is going to be a better correlation than the distance we did from the central location, why did we do the central location to begin with? Because
To identify the outliers.
yeah.
Get a better understanding of the.
But like that we can just keep as a parameter. We don't need to do anything. Like, but I am just creating an additional column with like that distance, like with like the drop off and pickup. I'm creating that function.
What are you calling it?
So the one this distance, I called it distance from NYC basically. I just changed the column name to distance from NYC. And then the other column which I'm creating like now with like proper latitude longitude difference, that I'll call like only distance. Yeah.
So there's the different kind of distance outliers. The actual distance, the high and low. There could be you could also do the starting distance from Grand Central Station. You could use that as well, but then you could use the ending location from Grand Central Station or wherever the center is. Could be another way to look at it. But but you want to do all of them.
Can you share me the code that you're using to calculate that distance from New York City, Aditya? Because I want to run that
Yeah,
too.
I haven't written it. I'm doing that now.
Okay, cool.
I tried to paste something in to the chat, but I'm trying to figure out the way to paste it in and have it remain like a code snippet, but it's not doing it for me.
Just do backtick, 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 Python, and then paste the code here. And then do backtick, backtick, backtick.
Which key is the backtick?
On the left of the one.
Oh, that's what I was trying to do. I was doing a regular, single quote. Okay. Right. Okay, there we go. So that was just, how to plot the two, two different latitude longitudes from each row. Although you'd have to change the names and so forth. So that was
Change the names.
yeah. I just called them lat1, lat2 rather than starting latitude, ending.
Pick up longitude or pick up latitude.
then-
What is
Yeah,
it? What is this dummy data though?
Oh,
Yeah, what's up with the?
that I didn't tell it to do that. That it did just to give an example of
Okay.
So should I
Well,
just pass in?
I just posted the code actually. You can see that.
Okay.
Oh, is that the?
It's that drop off to pick up location distance.
All right, so we got
Oh,
geopie.distance, row drop off latitude, row drop off longitude, row drop off latitude to row drop pick up longitude. All right, cool. So this will show the distance from this one to this one for every row, right?
Yeah, just change the column name like that distance. If you have kept the above column as distance, then change this distance. Like,
This?
I mean, you already have a column name distance, right?
Yes.
So do you want just to like overwrite over it?
No.
So give a different name or something.
Distance to and from. That's clear. All right, and then df apply lambda row. All right, cool. So then now if I run print df, then we see distance.
Oh, there is something going wrong, I think. I'm just checking that.
Yeah.
Some function.
DF at head.
What the distance? Okay. Oh yeah. So yeah, I changed the function names. So you can see there is So in that second function, find distance main. So you can see that df dot apply lambda row equal to distance underscore main. I just changed the function name because the above function was different.
Mm-hmm. No, we still don't have. It's still not there.
Oh, me's working. What happened? Like, no. Oh, you need to call that function.
Oh yeah.
Yeah, I just assign like. So this is how I did. So I just put on chat. So this is how I like.
Just find distance main, right?
I mean, I'll assign it to a different data frame, like df equal to find distance main of df equal. Yeah, okay, a new data frame. Yeah, that also fine. I just assigned it to the same data frame.
All right, so we got our df with distance. So find distance main with our data frame passed in, and then that should be good.
No. So the print you need to print that df with distance data.
Yeah. I just realized that.
That's fine. I'm let it run. You don't need to like stop it. Okay.
All right, cool. Is this is a function that takes a long time?
I mean,
Yeah.
it's the same time what it took for center. So,
6 minutes.
6 minutes? I don't got time for that.
well, I mean, it shouldn't take 6 minutes. It should be done before that.
I'm just playing.
Now you can so I have basically did a local setup in my like this Jupyter notebook local setup. So the notebook is the same format in my local. So I can see the time also how much time is that been since I've started the run. So it's been like 1 minute 47 seconds.
Okay.
Cool.
Yeah, no sweat. And then
Then
Sweeper, did you find a way to modify that function not with dummy data?
I don't think the dummy data was just showing how it was assuming that our data looked.
So we're passing in data here.
I think you can like comment that out or
And then,
If-
so what data are we passing in here then?
So the same, like our data frame is named DF, right?
Mm-hmm.
The one you're working with. So it should, if you don't define a new DF, then that's the one it should work with.
So
So
we're
like
creating.
the one,
It should be the data frame with just the pickup latitude, pickup longitude, drop off latitude, and drop off longitude. I think.
Yeah, they all have those already. So you're saying we don't need this line. We don't need any of this stuff here, basically, right? So.
right, right.
Okay. Yeah, that makes sense. Let's try it out. Can't hurt,
And
right?
if it doesn't work for us, then we could, plop this back in, change the name of the dummy data, and see what it does. Without our data, and see if it even works, or if it's,
Yeah, we'll just wait for this right here.
and that should
All
give
right.
different color dots.
Mine is done within a minute. I don't know for you why is it taking so long. Mine got done within a minute.
Yeah. Probably because you're running on local, right?
I wouldn't say that, like, because it's not like a complex computation. So it shouldn't actually matter. But not sure.
I told ChatGTP we already have a DF, and so if you run into a problem with trying there, I put in the next one to try. And now I'm trying to tell it, hey, okay, next thing, if everything works, let's try. Let me see if you can draw a line, if that's possible.
Yeah, I wonder what it's gonna look like.
Yeah, I don't know why it's having so slow.
Have we chosen a model? Because based on the correlations, you said we'd be able to determine whether we needed a linear model or something else, or do we still just not have enough information?
No, but the correlation is really bad. So if like we need to see the numbers, I don't think like plot. We need to see the plot.
So how would you know if
yeah.
it was? How would you know what model is required based on the correlations, though? That's what I want to know.
So basically, let's say if there was a factor which was like linearly correlated or like quadratically correlated. So if
What
it's
do you mean?
linearly
What do you mean? Yeah.
linearly means like let's say if I increase like a one variable by like 10, the other should the output should also increase like approximately with the like if a particular variable increases by like 10 percentage, the other variable should increase also by like 10 percentage. like so if like you can see like when you plot two parameters on a graph like x and y, you can see how the plot goes, if it's like linearly increasing or if it's like quadratically or like cubically increasing, and that way you can understand if it's a quadratic relation, like a non-linear relation, or like a linear relation between the variables and the output variable.
So basically, so whenever, let's just say we have like a linear relationship in the graph, if we can like best fit that with like a line, then that basically shows that there's like a linear like model that we can work with, correct?
Yeah, like a linear regression model.
But you can't tell that just by looking at the numbers, can you? If there's just, or
So
if
that's why I
there's,
said like you need graph, like you need to see some kind of graph.
well, what if there's just one like pickup? Let's just say distance was positively correlated, like it was like 0.8, for example. That would be linear.
No, that's what I'm saying. With numbers, you cannot say. With numbers, you can only say if they are highly correlated or not correlated. But like if they are positively correlated or negatively correlated, that's the only thing you can say. But you cannot tell like how they are correlated. You need to have the graph.
So you can see if there's a correlation, but you can't tell what type of correlation.
Yeah, like I mean, like it's what's the basically instead of saying correlation, what's the relationship between the two
So so we
variables?
so we so we basically just need to see a visual graph that shows the data, like any kind of function that basically shows mathematically, correct?
Yeah, how to see the relationship.
What's taking so long for this to load, Aditya? It's your function.
It's not my function. It worked in my system. It worked in my system, so I'm not sure like what's happening in your
You
system.
can I just switch over to local? How can I just do like connect to local runtime?
Yeah, do that. I don't know like why it's taking like I mean I didn't do that. I basically did a local setup on my VS Code basically.
Oh, there we go.
But
All right,
still
this
like
distance to and from.
yeah, it's correct. It's correct. I have the same values.
Okay, cool.
But for me it took a minute. I don't know why it took so long.
All right, cool. And then I need.
So there is still not a good correlation. I can see. I saw.
You tried it.
Yeah, I mean, I need to see I like that correlation factor. I know, but like, I feel like I need to see like how the relationship is there between the features, like through a plot. I usually don't understand numbers. Plots usually give me a real, like a good visualization. I need to see plots.
Mm-hmm. Hey, Sweeper, there is no module named
It says
Cartopy.
install Cartopy at the very bottom left.
Oh. Alright.
Or to plot, basically, you're saying.
Import. Oh, here we go. Let me just run this. It should already be built in, though, shouldn't it?
Maybe, yeah.
Oops. What's up with this, Sweeper? It's your function.
Hey, Sweeper, can you wait? Actually, is there another package we can use instead of this?
I can ask it for a different one besides Cartopy.
Yes. Someone that works with Jupyter.
Okay.
All right, let's see what we got here. It's working. All right, and then we also want to do a correlation matrix with the distance one. I want to see this. I know you already did it, but let me pull that up here.
Oh, yeah. Oh, you're installing it. Okay.
DF with
Oh,
DF
interesting.
DF with distance. So DF with distance. All right, and then this is just loading here. All right. I wonder what this library even is. All right. This better not take another 6 minutes, Sweeper.
You know what? Try it on 10,000.
I already started. Can't go back now.
Oh, what did that Cartopy start working, or do you need a?
No, it's working. It's working. Collecting. Yeah, it's successfully installed. So now it's just doing whatever this is. Cartopy is a Python library designed for cartography and geographic data processing. It's widely used for creating maps and handling geospatial data in Python. Okay, cool.
I use Leaflet, but I use it in R. So Leaflet is like great for like spatial because that's my work. So I do that data GIS visualization, but I do in R. I don't do it in Python. So in Python, there's a library called as Folium as well, which does that.
Yeah, that was the next one. The ChatGPT. When I said ChatGPT, what if we didn't want to use Cartopy? It said Folium.
What it is? And how do you spell it?
FOLIUM, and I'll paste it for our records here.
Folium is Python. Oh, you could use it in R too. Leaflet. Okay, gotcha. Interactive maps.
Leaflet is interactive map. Leaflet it's Leaflet is great. Like you can do lot of stuff in Leaflet,
Yep.
but like I'm not sure like in Python how to use Leaflet.
Now it says Folium is a Python library used for creating interactive maps. However, if you're working in R, an equivalent library is Leaflet. So it looks like use Folium with Python, Leaflet with R.
Yeah.
They have Leaflet in JavaScript too. Cool.
Yeah, Leaflet, like the Leaflet library is of JavaScript. R is basically using it as a wrapper. So Leaflet is in JavaScript, like so all those maps which you see on created on websites, they are through either Leaflet or there is called as map deck.
Oh, gotcha. All right, cool. Well, that's good to know. At least I know for the future now. I do have something else I want to share with everybody. I came across this course that I thought was pretty cool, and that would definitely benefit anybody who takes this this machine learning stuff. This is because we encounter so many different statistics words. So if it's called the Data Science course, Complete Data Science Bootcamp 2023, and they talk about like all the probability, combinatorics, Bayesian inference, distribution, statistics.
Oh, it gives you everything.
Inferential. It gives you like everything you need to know about statistics basically, and then it even goes into like Python and how to work with statistics in Python.
Probably buy that.
And then it goes over to, advanced statistical methods like linear regression, multiple. It goes over like cluster analysis, k-means, so mathematics, deep learning, introduction to neural networks. Like this course is really solid.
Oh.
Yeah, I'm probably just
And
gonna
what do they want?
Huh?
They want money for this?
Yeah, it's probably like $10.
Yeah, it's money. $10.
Oh, $10.
Yeah,
That's not bad.
don't buy it unless it's on sale. That would be my recommendation. But yeah, it's I'm doing like a lesson a day. I don't like tutorials, but I think like just one a day kind of thing in the morning.
Yeah, post a link to that.
Yeah, I might use that actually.
Grasp the concept.
Oops.
Grasp the concept. We must first explain what an experiment is.
Yeah, they have good animations too. Let me see. Alright, I'll post this. It might.
You guys know the Monty Python, not Monty Python, the Monty Hall probability example?
Nah.
Oh, that's the let's make a deal example.
Nah.
No.
Okay. Well, this one you want to know because it's so fascinating, and it doesn't make sense to people. And if we're waiting for this thing to run, I'll tell you about it. But first of all, do you know the show Let's Make a Deal?
Yes.
Yes.
Okay, so it used to be hosted by a guy called Monty Hall, and now it's hosted by the comedian. What's the guy's name? I can't think of it, but it's on today with the guy. Can't think of his name, but so at the end of the show, you have to pick which. There's 3 curtains. You have to pick the one you think the prize is, and the other ones are, zonk or bad things. So you get to the final, and your odds are basically 1 in 3. So you pick one, and then the host says, "Okay, I'm going to show you what's behind." Let's say you picked number 1. He said, "I'm going to show you what's behind number 3," and it's a donkey. It's a zonk.
Oh, I think I heard of this now. Yeah.
Yeah. So he asked you, "Do you want to change your choice?" And most people would say, "Well, no, I've still got a 50-50 now." Because you took one away, so why would I don't need to change.
Oh yeah.
Actually, the odds are that you want to switch.
That's a old mathematical problem, probability. It's shown in movies as well. Like there's a movie called as, I think it's a true story of one of the students from MIT.
21.
21.
Yeah. That
They
movie.
have shown the same concept there.
Yeah.
It's a old mathematical concept, like probability concept, where your odds, you're like it's basically your odds are divided by like 1/3. Basically, it's something like that. But yeah, it's a old myth. So it's from a movie they're shown. So when I saw that scene, I was like, I went to see that concept actually, like what that concept is. But yeah, it's a great concept.
You know, I said, well, let me program this and write a program that, you know, does the choice and prints out the output. And it's like, well, that, because sometimes you can hear this and you can be like, oh, I don't believe that, because it's not always easy to find a real good explanation of it. And there are different sources that explain it better than others. But I thought it was a fun thing to program, just to like see it, and you see it happening right in front of you, as you know, if you make that choice.
Yeah, I think anything with understanding the concept, if it can be programmed, I think that's like a excellent thing to, you know, dive into. If it's programmable, then you should definitely try to program it. So.
I'm gonna go. I just deleted that. It's just taking way too long, so I'm gonna try to just do the correlation. Though this is looking a little slow too. I don't know if it's just my notebook or what's going on here.
The correlation is slow in my as well. I have just did one. I'll put that code, see if it runs. This is the code. Just change the column names. Like the trip duration is fine, but I'm just checking the trip duration with that distance and distance from NYC.
This here.
So yeah, I'm basically that distance from NYC, that's central, and then the pickup minus drop distance. So you can just change the names what you have in your data frame. But it's still taking time. I don't know. It's been 4 minutes. Like, I'm not sure what's the problem. Let's see if it runs in yours.
Heat map as a train DF. Why are you using the training DF?
Oh, that's what he just created. You can just use DF, yeah.
Alright. For some reason my circle is going slow. The SVG or the icon is spinning slow, so we'll see.
We need a supercomputer to run this stuff on.
Oops. Oops. I think mine's just, oh yeah. Alright, let me see if I could connect. If I do connect to hosted runtime, does it connect to mine? I know Aditya, you already did this.
Don't do. If you do that, you need to run everything.
I know, I already clicked it, so everything already deleted. How do I
Oh.
how do I connect to mine though? Because that'll be way faster.
Yours, as in like your local system.
Yeah.
Check. Like I'm not sure like how to do that. But I don't know. Like it shouldn't be this slow. Like there's some issue going on today.
I know. Hardware, when working with Jupyter, you need to run Jupyter Notebook server on your local machine. Here's a step-by-step
Some issue
guide.
going.
Install Notebook, Jupyter Notebook.
Oh yeah, you have to install Jupyter Notebook on your local machine.
If the browser doesn't open automatically, you can manually navigate in the terminal. You see something, create or open a notebook.
If you have Visual Studio Code, then there is an extension of Jupyter Notebook you can do there as well.
And then I could just run it on my machine.
Yeah, you will see a Jupyter Note like exactly like you saw this Google Colab, exactly in that format you will see in your Visual Code. So just
Alright.
like go to Visual Studio Code, and then there should be an extension of Jupyter Notebook. Yeah, good. Like, but you would need to like copy all your code there.
Mm-hmm.
But I'm also like a bit surprised. Like now even my Visual Studio Code is slow for some reason.
Alright, so now you said the extension, Jupyter.
Yeah, search Jupyter. There should be an extension. Here's the first one. Yeah, and then when you go to command palette, like just go to like command palette.
Here.
No, Control Shift P. Yeah, just type Jupyter Notebook. Create new. Yeah. Yeah, and now just keep on adding your code. And that
Oh man, I
you
can't just
would have
copy
to-
it all at once.
This is Jupyter Notebook. That's Google Colab. But you need to install the libraries as well here. But there should like don't not that. Oh, you need to get your data set here. You should have that data set in your local, right?
No.
No, when you upload it to Google Drive, you upload it from your local, right?
Oh yeah, for my desktop.
Yeah, so it should be there. Just put that data in that folder where this project is. Not like
Right here.
yeah.
Nah.
Just unzip it. Like you need to like type that code to unzip and all.
Yeah. All right, cool.
I mean, it would take some time. Like it took me like it would, but still like I'm like still surprised. Like why exactly everything is slow. Even my Visual Studio Code is slow now.
It's still unloading for you?
Yeah, it's like for me also it's slow for some reason. Everything.
Let me just unzip
I'm
these
not
right away.
sure what happened. Like
Is it that function that was it the distance function that makes it making it?
no, my everything is good. My correlation heat map to see that correlation, like not heat
Oh.
map, but the correlation that is slow for some reason.
Really?
All right, cool. So we got our add folder to workspace. Should I add the folder or just the file?
Just the file. Just the file. Drag that file. Just drag the train.csv for now only because you need that only.
Train. Okay, cool.
Yeah, I mean like you don't need test for now, so you can do that later. You don't do that. All that shit. You know, it's just
Don't worry.
yeah.
Don't worry.
You can save that file. Like if you.
All right, cool. So I got this. Now I just need to go ahead and paste the stuff from here into my code editor, and we should be good to go.
Yeah, yeah. You don't need to paste everything. Like just copy. Yeah, right.
Well, I also don't need to paste
No.
this. We already did
Directly
this.
train.c. Yeah.
Let me just
correct.
make sure I have my. All right. So if I run, oops.
Remove that train slash. You don't need train slash. Just train. And save that file first in that location because it might not work. Just controls. Yeah, okay, that works.
Right here. All right. We'll just call it taxi.
No, change. No. Change type. Save as type. Change it to all files and do just do all files and do ipynb dot taxi dot ipynb.
IPYNB.
ynb. Yeah, that's the extension for Python notebook.
IPYNB.
Yes.
Yeah, IPython notebook.
Yeah.
All right. And then
Now-
how do I
yeah,
how do
now
I
just-
how do I run this block of code right here?
No, you can just no. You should be able to just. There should be a.
I just want to make sure. I just want to make sure I have the training set. How do I run? Oh, right here.
Yeah. Oh, you need to set the environment. Yeah, that's why you're not seeing options. Yeah, click on Python environment. Yeah. Okay. You don't have Python.
No. Yeah, I do.
Okay. Do one thing. Go to command palette again. Just go to command palette. Just type Python. Select interpreter. Yeah, and set that first.
Here we go.
Yeah. Now it should run. Now you can just click.
Yep. Okay, cool.
And now just you can see there's at the left you can see, yeah, just click on that. Why is it like requires? Oh yeah, you need to install just install it. You need that IPy kernel package for that.
All right, cool. So then I should have that. We'll go. I could go ahead and take time to do all this other stuff.
No, directly do the like the find distance. You don't need to do that.
Yeah, that's what I'm saying. Like, let me just find out what I do need though. Group by.
Yeah, sure.
Group by. Describe, sort values, distance. No module
Like,
named
yeah,
Panda.
install all the modules.
Yeah, so what you can do is uh, just there's one more thing to do, like just create one more code. Just create a code.
Up top.
Yeah, just you can see no, like a separate code box. You can see plus code sign at the top. Plus code, yeah, that will add a box. Just do amber like exclamation mark pip install pandas and just run that.
Okay. And then
Yeah, once it is run, then you should get that pandas thing removed.
all right. So this created our distance. So I need this one.
Yeah, you could just keep this box, like this code box, separately at the top, so that whenever if you want to install something, you can just type there, change the library name.
Okay.
Okay, it's not working.
Nope. That.
Okay, do like go to your.
It says use symbol instead of exclamation point. Let me try that.
That's like a warning actually, but
All right, there we go.
no. Okay. Oh, great.
All right, cool.
Yeah. Now you can like just keep on copying your stuff.
Cool.
Oh, we need to install that too.
Yeah, I think that correlation thing, like it for those many records, it like screws up.
So now you're telling me I have to install everything again?
Yeah.
Not, I mean, there are like not too many packages, so that's fine. I think, yeah, you could just do I think, yeah, it should be just GOPY. Don't do the dot distance.
Then I take the whole library though, right?
I mean, dot distance isn't like it won't just install dot distance.
Okay, so that ran there. And then I did find distance. Okay, so I need that one.
Yeah.
Make sure to store it.
Just do df equal to find distance.
Yeah.
Yeah, that's it.
There we go.
This should be fast because this one
Yeah.
ran fast for me. It should like not be more than 2 minutes. You can see the time, so that gives you like a good thing to know that something is how long it is taking.
Yeah, nah, this will be quick. I wonder how much it actually takes on my CPU though.
And this shouldn't take too much.
It's using only one core.
I mean, yeah, I mean it's like a single thread work, right? So it wouldn't take much like much C processor.
I wish that you could just spread it out among all the cores, you know? Be way faster.
So you need to do that explicitly. That's what I said. Like Python doesn't do implicitly multi-threading.
Yeah.
Use Rust.
Which language does it implicitly? Rust?
I think Rust Go does it, but I think I'm not sure if like in Go also you need to define Go runtime. No one does it explicitly, like implicitly.
Okay.
You need to write a code for that.
Let me.
Okay.
I'm just
I
gonna
think,
get this ready. I can start building out the boxes while I'm doing this, anyways, and just so the code is ready.
Yeah. You can just keep on copy pasting the stuff.
Yeah. And then that's really like the longest one, anyways. I think. Distance. All right, so we're basically where we were anyway. So. All right, cool. DF with distance.
What's another distance one?
DF with the other distance, yeah. So then we
from the
had
center or something?
Seaborn. This was the one that you had. All right, so good. We're at least where we are here.
Check. Did you get the latest one that I did that has the lines? Well, I guess try the colored dots before the line.
Yeah, Aditya
blows up.
sent this one and said it works for him. Did you try yours in your code editor?
Me? I didn't try it. No, I didn't.
Yeah, okay. We'll just go with the one that he already tried out then, just to be safe.
Yeah.
All right, so we have.
Yeah, I'm
Alright.
just reducing the data now for that correlation heat map because that large data set is going very slow.
All right, so pip install matplotlib. Cool. No module matplotlib. Huh. Do I have to do the hashtag? I mean, the percentage symbol for all of them?
Yeah, I mean, whichever packages you want to install, you have to.
But you said exclamation point. Name it.
I mean, I am using exclamation point. I think it's deprecated. So, but in my, it's working. It's not like, I think it's deprecated and they changed it to %, but exclamation works actually.
Okay, cool. Well, we got this. Good. We got this. We got our correlations. We got our functions. We got our df with distance. All right, I think this one might take a little bit. Yeah, so this is the one that took just a little bit. Hopefully, before it took 6.5 minutes. Let's see if it's quicker on this one. Because if it saves time, if it's not 6 minutes again, then this was good at least making this transition, so it's much faster moving forward. Alright, cool. I've never actually used Jupyter Notebook inside of Visual Studio Code, so now at least it's all set up and ready to go, you know? 0.1 seconds. Oh, okay, and it shows you how long each one took. Yeah, so this one took 2 minutes, whereas in the Jupyter Notebook it took like 7 or 8 minutes.
Yeah, I mean, like, that's not certain. Sometimes Jupyter Notebooks works fast.
Faster, yeah.
Google Colab, sorry, not Jupyter Notebook.
Yeah.
I mean, so there is a subscription called as Google Colab Pro. If you get that, then like it's next level.
You know what I want to do is I want to just take a day to like set it up so that I could do the multi-threaded thing and I could just spread it among all of the cores. Then it'd be fast. It'd be like a couple seconds, you know?
Yeah, you could do that. How many cores you have in your system?
16.
16 cores.
Yeah. 64 threads.
Yep.
So it'd be fast. It'd be definitely like just a couple seconds, you know? And that would be best for these videos anyways, like when we're doing the streaming and recording and people are watching. Like, man, if you have to wait even 3 minutes for something, it's like, come on, man. If we could do it where it's just like under 10 seconds, even with a 1.5 million data set, that's nice, you know? It makes a huge difference.
Yeah. I've just posted one more function.
Mm-hmm.
Like you can actually use this function to like randomly sample like any number of records. Like if not the entire population we need to test. So it basically randomly chooses like n equal to, I give 1,000, but you can do it like 10,000 or something.
DF with distance, right? Sample.
Whatever data frame you're using, yeah. I mean,
Yeah, I'm using with.
I'm basically using the same data frame and updating that same data frame for everything.
Mm-hmm. I'm not seeing. Okay. I'm pretty sure it's there though. All right, and then we got. I do need to. How do I move this up? I need to install. So pip install Seaborn.
Yeah, I'm just seeing like
Cool.
I got the plot, but it's like I don't know. I don't understand like how they are plotting this correlation.
DF with distance, not an index. Oh, it's not DF with distance. What is it? What do I call it? Distance to and from.
Okay, one second. The heat map is not good.
It's not good for you.
No. So what did they like in this chapter 2 Google Colab? What exactly did they do to visualize the correlation? They did something.
I mean, if you look at the data set, it's all this stuff here. So using.
No, in the Google Colab, like the chapter 2 Google Colab, basically end-to-end machine learning. In that, I'm saying.
Yeah, this is the end-to-end. This is chapter 2.
Okay, yeah. So if you go up, like just keep on going up, there should be a correlation they did. I think it was at the top. They did some correlation.
It was further down. It was this here.
Yeah, this one. Yeah, this one. No. The after that, like this plotting, you can see this one. We
Yeah.
need this.
Oh yeah, you get to choose which ones. You get to choose.
Yeah.
Which...
Can you like post this in the chat? I am also right.
Okay. Cool. Still waiting on this here. Cool. And then I'll go ahead and post this next because I do want to see that. But from pandas plotting, import scatter matrix attributes. What attributes are you going to do?
For now, I'm doing just distance from NYC and trip duration. But we need to. I'm trying to change. I'll also change that time to timestamp and use that. So I didn't check that yet. I have to yet to convert that in timestamp. So I'll do that as well.
Trip duration, you said?
Yeah, trip duration, distance to and from, and to like distance, just distance. I think, right? You
Just
had
regular
just
distance, yeah.
And from distance from that center NYC. You don't need that actually, but like I'm just using that just to like see if there is anything like that.
Mm-hmm. Save fig, extra code. We don't need that. All right, cool. And then I'm thinking what other attributes do I even want to see? So like passenger count. There's such a tiny correlation. Though I do want to see. I want to convert the connectivity, the network connectivity, to numerical data, and I want to see the correlation there. And especially after we cut out the outliers, I definitely want to see that. I guess JH called them artifacts, which you wouldn't call them errors. They're technically you would call them artifacts.
Who?
JH, I think John.
What artifacts? To what he called artifacts?
Like where he said there was like the latitude and longitude, or certain data was picked up like in San Jose or over the ocean. He actually sent me a message yesterday. I'll go ahead and share it with everybody. So I said, how did you know to create the distance attribute? What led you to that? Just experience, or are you thinking about this stuff in a certain way? I sent Aditya a similar message too. But I don't think you were talking. I didn't ask Aditya about the distance attribute. I asked Aditya about the velocity. Yeah. So I was curious about why JH said distance and why Aditya came up with the velocity. And I liked Aditya's answer too on just like thinking about physics. If we have distance.
Yeah, for me it was pure physics.
Yeah, that made sense. And then JH responded with, well, the problem statement asserted that in the business domain, there are New York City cab fares. So the pickups are in New York City. So if the pickup coordinates are outside of New York City, then it's a mistake, which has a lot of regulations and culture surrounding it. But when you look at min-max of lat longe, we see crazy figures that are very, very far away from local locales regulated by the TLC. So that immediately suggests there's either measurement error or that some collection process injected artifacts into the observed data set. So from there, I was just asking the question, could this row plausibly be explained by an actual paying customer adhering to the published taxi tariffs, as opposed to some data collection artifact? Like in one instance, we see that what appears to be a cabbie who lives in a suburb north of Stamford, Connecticut, who clicked on and soon after clicked the meter off, likely while approaching his driveway. Or in 2 instances, it's crystal clear that some lab tech at the Verifone Automation Anywhere Meter Service Center in San Jose, California, flipped the meter on and then flipped it off without ever visiting a medallion taxi. At that point, we don't even need to discuss all those lat launches in the far north Canadian wilderness or deep in the Atlantic Ocean. Maybe a taxi was on a boat? Nah, more likely someone played with the meter while flying into the East Coast airport. So there's like these artifacts, there's like this information in the data that we just, I believe we need to cut out.
Right, and so these artifacts are like inconsistencies that exist within the data set. So we just need to filter it.
Yeah. So once we cut those out, and then we look at the average time.
Jim, don't do DF. Do like the RAN DF, because if you do that DF Seaborn, like that is going to take a lot of time. You did like on the entire data set. Just stop that.
This one, stop.
Yeah, I mean, like that's not a correct good correlation. Don't do that. Ignore that. Yeah, just do like but it will. Oh,
What?
it's going to mess up the entire Jupyter. I mean, that correlation, what you did, correlation matrix, you did it on the entire data set.
Yeah.
So I was like, entire data set is taking a lot of time. Instead, like, I did it on like that. That's the reason I gave you that RAND function, right?
These are good though. It didn't erase the rest of the Jupyter notebook. We have checks here.
Oh, let's see. I'm not sure.
Yeah, we're good. Although this is still, yeah.
Yeah, I mean, because that is going to like.
Can I run them
can't you, like-
simultaneously?
You can see that run all function would be there at the top.
You can't use a keyboard interrupt like to cancel it.
Nah. No, you can't do that. I mean, it's not running. It's not running as a background process, right? I mean, it's basically the Jupyter, this kernel, it's running as part of this kernel. So if you want to stop it, you basically need to stop the entire IPy kernel. You cannot stop just one element.
Can we just let it finish?
You can let it be. I mean, like, I'm not sure. So what I'm doing like parallelly is I'm trying to plot the latitude, longitude on a map.
I could see. Okay. Did it complete yet?
No, I'm still like coding it. I just started coding that. I saw the code. Let me share my screen.
All right, cool. Yeah, we got a couple minutes anyway, so I'll go ahead and keep running this. I'm gonna go ahead and run all terminals tomorrow, like 10 minutes before or 15 minutes
Yeah.
before even the meeting, so everything's just ready to
Oh.
go.
So this is how the correlation looks for like trip duration, distance, and distance from NYC for like random 10,000 samples. So these ignore it. Like you can see there is a correlation from distance and distance from NYC, which is obvious. Like there should be, because we are using like, but this part you can see like there is not good correlation with the trip duration for these two elements.
Wait. Say that again. There's not good correlation between distance and
Trip duration and distance from NYC and trip duration.
Well, aren't they? They look like straight lines to me. You know, straight, almost vertical lines.
I mean, straight lines. So basically, it's like
I mean,
Straight
when you
lines
look
is
at
the
the
best
when you look at
correlation.
when you look at the very top right and then top middle, it's like that's like
Top
the same
right.
graph, but like in the other axis.
these two and these two. You're saying, right?
Yeah.
Yeah. I mean, like it's basically. So as the distance. So distance is basically the way distance is increasing. Like for short duration, the distance is increasing pretty high. I mean, like for large distances, the trip duration is very small. Like even if the distances are too large. That's what this is telling. Like basically it's telling like
Well-
even if like you increase the distance highly, it's not affecting the trip duration much. That's what I'm saying.
Okay. Okay. Well, you know, that could be a delimitation of the trying to that we're not really the Latin line are not true distances. We're it's all mixed up with the roadways of New York City.
Correct.
So
Yeah. Right.
um the just it's we've got this almost to sort of check for what things that are breaking the laws of physics. You can use that distance, meters per second to say, okay, these ones are impossible, because you can't drive at the speed of light, and so that could help get rid of bad data.
Yeah. We could do that. Uh, like the thing which I'm trying to see now is like, so I'm trying to like plot on a map, like all those latitude, pick up latitudes and pick up longitudes, and see like what clusters they are forming. Like I'm trying to like plot like a heat map clustering on a proper like map, and seeing like how those point like what clusters are forming, and like how far those clusters are from the like from the main NYC, like the city, New York City. So
Hmm.
that's what I'm trying to. I would be plotting. Like I was thinking of plotting now after this and seeing how they, because that's so that I feel like, because if you see like these parts, yeah, you are right that this pickup latitude, longitude, and drop off latitude, longitudes is more like kind of like if we like just get the distance, it would be like an ideal distance, not like with noise, because like there has to be some penalty based on like the roads and the turns and all. It won't be like just straight distance, right? So that doesn't make sense to get the distance between them. I'm not sure if there's a library where we can get the like the distance, like the road distances. So if I could find that library, then we could use that. Uh, these two factors, like yeah, I mean, this factor obviously it's not doesn't matter to get the correlation, because this is just to like identify the outliers. I mean, it's nothing to do with the correlation with the trip duration, so we can ignore that this for trip duration. But the thing about date time, that could be one major factor. But regarding the location, like I want to see like if we could remove the outliers, like for based on the pickup latitude longitude, and only consider the pickup latitude longitude or drop off within like the NYC, then we could see I feel like we could see some correlation,
Do you think
probably.
a geographic like data map of like the longitude and latitude would like give us a better representation of how these are correlated?
You could, yeah. So I'm just trying to see like because like
Can
this
I
pickup
can I ask something really quickly? So I'm also thinking about like if someone picks you up on like Staten Island or somewhere outside the busy parts of the city, then the pickup time is less relevant than if they pick you up in Manhattan or one of the busier places. So is there any way to combine the pickup longitude and the pickup latitude and the time to see what the correlation is? Like the combined attributes, like pickup longitude, pickup latitude, and time.
The trip duration, right?
location and time.
Location and time, yeah. Because if you're picked up at a specific, yeah, what does that attribute make?
I'm just seeing. So that could basically not help us to see the like we cannot combine that as a column, but there is this algorithm called as DB scan algorithm. I don't know if you've heard. So it's basically a clustering algorithm. So that will basically using those two parameters, we'll be able to find out like which are like the clusters formed, where like the time is the same and the location is the same, and that will form like clusters on the map. That is one good way to visualize the data. But like combining them as a column, I'm not sure if you can do that.
Yeah, I'm trying to think of how you could combine that because I could see how being picked up in a certain location at a certain time is going to affect the duration. That just makes sense to me.
Yeah, I mean, uh, uh, yeah, I'm not sure how you can combine them. Like, there is no metrics to combine location and time. Distance and time only is the way. But location and if that's what I'm saying, like if we could get like some metrics to calculate like the distance between latitude, long bit pick up and drop, but not like uh like the Euclidean distance. I don't want that. Some other metrics. We need to like I need to do some research on that to see like what are the different ways, because if we use some kind of tile layer of like 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 the map like of like New York City, there should be a way to calculate the distance through roads basically.
You know, help me. I've been thinking about the distance, but let me say this, and it's something to think about. So the distance as we have it between two points is the minimum possible distance.
Yes.
No, if it was on a straight road, no turns, then it could be a straight line. It's the minimum possible,
That's the minimum distance which we have.
and it could be higher. So if you're using what we've got as the minimum, then the minimum, and we turn it into the speed, you've got the minimum speed that they could have gone at, and then which could be higher. And when you've got the minimum speed, can you do anything with that? I mean, where would you say, well, it's too slow? It's too slow to be real, but then you don't know. Well, what if there was a traffic jam?
I just found something useful. Go ahead, keep going though.
But I'm thinking this through. I'm trying to see. Am I making sense here? Am I thinking correctly? So the minimum speed that they're going, if you want to say, okay, we can cut off these because it's, in a ordinary environment, you could say, well, if the car is going like super slow, something's wrong. But then you have traffic jams, which could account for that.
I mean, the speed does relate to trip duration, correct? So like, you could possibly use like velocity as a means to correlate the data somehow, right?
All right, I have an idea.
It could turn out to be informative, but I'm saying, one of the things maybe if we have the minimum possible speed, I don't know what we can do with that. Now, if we had like because we don't have, we could apply physics to if we had like a maximum or a speed where we say like, well, they can't go at the speed of light. So I guess if the speed that we come up with, which would be the minimum possible, is greater than whatever 100 miles an hour.
How would you find speed though?
Oh, the distance
Divided by just
the duration.
By time? Yeah. Okay.
What were we gonna say, Jim?
Yeah, I was just looking at a couple different ways to combine these things. So a couple different ways is time located bins, which I don't really like this idea, but create bins or categories that combine both time and location. For example, downtown morning. But the thing is, this would be a couple of steps. So we'd actually have to take our coordinates and create bins with them to create either like neighborhoods or districts. And then based on those neighborhoods or districts, we could combine our neighborhood and district bins with our time bins, and I think that will give us some pretty good information, and I think it will give us some positive correlations. Though I like this one the best, time weighted location metric. So if locations are represented as coordinates, which they are, you can create weighted averages of these coordinates based on the time of day. This could help in identifying central points of activity at different times. And if we're able to get those weighted averages, then we'd be able to create a much better map for us to visualize. And I think that the time weighted location metrics would have a very positive correlation. I think this one would be very useful.
That sounds great, but I think we haven't done the basic map, and then we want to bin things on one variable level. You know, like we can bin the lat and the lon and the lat lon before we then also do it with the time.
Yeah, but that's a whole different thing. So I think with the time located bins, we're going to get much less precision. I think with the time weighted location metrics, it's going to be much more precise. We're going to have much more precision, and I think the model will be better. We could try both, honestly. I
might be agreeing with you. I'm just saying that, are you jumping, 3 steps ahead when maybe there's value in looking at it step by step?
No, because I'm just talking about creating. I'm talking about feature engineering, which is the step that we're in right now.
Right.
I'm talking about just adding features to the data set for us to use later.
Yeah, and with these features, we add more.
Okay.
We add more ways to exploit the data.
Even more. Yeah. It just gives us more information.
Yeah. So.
I think one thing which I need to first want to plot is basically on a map. I want to see the density of pickup and drop off locations. That's like the next thing which I want to do.
Yeah, which is the geospatial
Yeah, I want to see like what clusters it is forming, how it is looking in a map, the distribution. Like the heat map is also enough, and then that probably then we can proceed further with like adding a time parameter to it.
Mm-hmm.
But I feel like if we could see first that would bit helpful.
Let's do that. Let's do that tomorrow.
I'll work on that tonight. So.
Yeah, I'm also gonna work on it tonight or tomorrow morning. So before that, we could have something like that.
Okay, cool.
All right, cool. Sounds good. All right, awesome. I'll see y'all. Actually, if you're here for the data structure algorithm competition tonight, I'll see y'all in an hour and a half. Otherwise, I'll see you tomorrow at 6.
All right, see you guys.
See ya.